All right, once you've identified the intervals at which a function is increasing or decreasing, it's not difficult to identify or classify the relative extrema. And that is called the first derivative test. And think about this. If your function is going increasing and then decreasing, are you going to have a min or a max there? A max, good. I mean, just visualize it. Your function's going up, and then it's going down, so you've got a maximum. And then if your function's going down and then up, you have a minimum. So if f prime of x changes from negative to positive, which is the same thing as f changing from decreasing to increasing, then f of c is a relative min. And if f prime changes from positive to negative, then f of c is a relative maximum. So classify the relative extrema of f of x in example 3. Well, relative extrema have to occur at critical numbers. And how many critical numbers did we have in number 3? 2. So okay, you have to say the relative extrema are the extreme value, the extreme y value. So you can't just say at x equal such and such. You have to also have the y value. So my suggestion is just write it as a point. So let's start with the x values, though. So at x equals 0, am I going to have a min or a max? A maximum, because f prime is changing from positive to negative. And at x equal 1, I'm going to have a minimum. Okay, so, yeah, hold on. Yes. All right, so we have a relative minimum at, where was our minimum? At 1, comma something, and I'll go back and find that in just a second, because f prime of 1 changes from negative to positive. And I have a maximum at 0, comma something, because f prime of 0 changes positive to negative. They just require that you justify your answer. And that's the way you have to justify your answer. So on a quiz or a test, if I ask where are the relative mins or classify your relative minimums and maximums, you have to justify. It's just given. I try to remember to say justify your answer, but anytime you're telling me a relative min or a maximum, you have to justify your answer. An absolute min or maximum is justified by your table that you drew, hopefully on your quiz in your homework last night. Okay, now how can I go back and find the y values here? Go back to the original equation. So when x is 1, y is going to be negative 1/2. And when x was 0, y was 0. Okay. Everybody okay? I know it's kind of a pain to have to justify it. Okay, find the relative extrema of this function on the interval 0 to 2 pi. The way that you find relative extrema is to find where the derivative is either changing from positive to negative or negative to positive. So even though it's not asking for where the function is increasing and decreasing, I really have to go ahead and find that. Okay, same thing. Find the relative extrema for part B. Do I want to use the quotient rule? No. I want to rewrite this as x squared plus x to the negative 2. Everybody okay with that? Okay. So f prime of x equals 2x minus 2x to the negative 3. Is this derivative, remember, critical or relative mins and maxes will occur at critical points, which is where the first derivative is 0 or where it's undefined. So is this derivative undefined anywhere? Yes, because I could rewrite this as 2x minus 2 over x cubed, and you get an x in the denominator. I rewrote, instead of using the quotient rule, I rewrote the original function as x to the 4th over x squared, which is x squared, and then plus 1 over x squared, which is x to the negative 2, and then I took the derivative. Okay, so 2x equals 2 over x cubed. So 2x to the 4th equals 2. X to the 4th equals 1. And therefore, x equals what? Or negative 1, plus or minus 1. So how many critical points do I have? 3. Kelly? Because think of the absolute value graph, and you've got that cusp down at the bottom. That is a minimum of the absolute value of x, and so that's right. It could be undefined at a vertical tangent line, and so where that would show up. So like the derivative is undefined here at x equals 0. If that happens to be a vertical tangent line, then you're going to go like positive, positive, and not. That's where that's going to show up. Oh, thank you. Okay, sorry. Okay, so now where do I plug my test points into? The derivative. Okay, so I'm going to plug in a negative 2. I'm going to plug it into this line right here. So negative 2 is going to be negative 4 minus 2 over negative 8. So negative 4 plus 1/4. That's negative. Okay, how about a negative 1/2? It's going to be negative 1 minus plus 16. Positive 1/2 is going to be 1 minus 16. That's negative. And 2 would be positive. All right, so how many relative minimums do I have? 2. One of them is at negative 1 something, and the other one is at 1 something, because f prime of x changes negative to positive. Okay, how about a relative max? Just one. Where? 0, comma what? Okay. When x is 0, the original function is undefined. So at first glance, it looks like you have a relative max at x equals 0. But when you try and plug 0 back up into your original function to find that y value, it's undefined. So there is no relative max. The point 0 comma something, it's, well, what is happening on the graph of f of x at x equals 0? There's an asymptote. Yeah. Yeah. You could say, if you wanted to say no relative max, that would be fine. If you wanted to take it a step further, you could say because f of 0 is undefined. But no, I don't think that you would have to say why. But that's good thinking to, always want to try and justify your answers. In addition to your homework tonight, I'd like for you to do the back page of your notes, which is basically just, given the function, draw the derivative. We've done that a fair amount, so draw a rough sketch.